Hello and welcome. I'm Prateek, and in this video we are going to build a Flask movie recommendation system and also apply dimensionality reduction in using the singular value decomposition technique. In the last video where I created a Flask movie recommendation system, I did not apply any dimensionality reduction on that. It was just using a Tf-IDF vectorizer and consumed very high RAM for data preprocessing and recommendation task. But once we apply dimensionality reduction, you will see how computationally efficient the whole process can become. So this is what our ultimate movie recommendation system is going to look like. And this is where I have already trained my model. So this is the process, where I train my model on Colab, and then I saw that how the LSA dimensionality reduction is performing, and here was the result. So I have already created a video for this thing. Now we are just going to use the same code in our Flask application to build our recommendation model Flask application. So in this, what we did is we just imported the IMDB movie dataset, which I created after performing multiple data pre-processing tasks, and then I created a new column called content, which we used for our recommendation feature extraction method. So we converted it into bag of words, then we converted it into Tf-IDF, and then we applied the dimensionality reduction, and we used the LSA model there. So all these processes were pretty quick, and I was not even using a lot of RAM for this task, and it merely consumes maximum of 2 GB of RAM for everything. And when I apply, so the task that takes the maximum number of time is this task where we try to train our model and creating the LSA model. So it takes around 1 minute. There is, so right now what I'm doing is I'm following the same process. What I do in my Flask application is import the dataset, which I already have, the IMDB movie dataset, then create a new column called content, then do the vectorization, then create bag of word, and then convert that bag of word to a Tf-IDF, and then finally apply the LSA model. So if I try to run this whole thing on directly on the application, it takes a while, and that is because when we are trying to fit the LSA model, that is where it takes around 1 minute to train. So that is the reason, when I run this, restart this Flask application, it takes around 1 to 1.5 minutes to actually start. And then after that, once the application has started, it is pretty fast to give the recommendation. So that is not a problem in that time. But if you want your application to start faster, one thing I would recommend, what you can do is you can just export this, basically dump this trained model, LSA model, and then again load it back here on your Flask application. So how that is going to look like is this. You'll have so there is this package called job library, JOBLIB. Earlier it used to be a part of sklearn, scikit-learn, but then now you have to import directly job library because it's not a part of sklearn, I believe, anymore. So once you do that, you can directly load the trained model. So what I did here is on the Colab, what I did is I trained it, and then I dumped it as LSA model.joblib file, and then I just loaded that model here. So basically, starting this Flask application was way faster. It merely took me a few seconds to start this compared to this one, which takes around 1 and 1.5 minutes to start. But there is a problem with this one. The kind of recommendations I was getting using the trained LSA model was very different and not that good as of when I was training my LSA model in the Flask application. And there could be multiple reasons behind that, why that was happening. So I checked a couple of things. I checked that all the packages that I'm using, the scikit-learn version I'm using here, and what I was using on my Colab are same. Similarly for job lib package, I checked that, so that was not an issue on my side. Then I also checked that the setting for my Tf-IDF transformer and vectorizer are same. So I was not really able to figure out, why that is happening, why I am not getting the good recommendation. If I just try to, import the loaded model. If you know why that was happening, probably you can tell me in the comments, and I'll be happy to learn that. I'll keep on researching on that, why that is happening, and if I have an answer, I would definitely let you guys know in the description or in the comments below. So for now, I am not importing any trained LSA model, but in my Flask application, once I have my Tf-IDF created, then I use that, and I just use 100 components. So the dimensionality reduction, I don't know how many dimensions are there, but there are probably thousands of dimensions when I create my Tf-IDF. So I reduce that to just 100 dimensions while maintaining the semantic relation between all these dimensions. And then I use this to finally, get the recommendation. So this is where I'm getting the name of the movie from the user, and then I search if that movie is there in my data set or not. So the IMDB movie data set that I'm using contains basically movies starting from 2000 to 2022. So all the movies are there. Let it be Hollywood, let it be from any other country, all the movies are there. And then I check if that is there, then I go to the next steps. If it's not there, then I just say that movie not found, please try again, or please, mention some other movie name. And then I calculate the similarity score, and then I just, recommend the top 10 movies. So let me just change this. Okay, 10 is fine. Or I can increase this to 21, and then I can just restart this application. So yeah, so once I recommend top 20 movies, I just show those movies in my recommendations.html page. So the HTML files that I'm using basically goes under my template folder, and the CSS file goes under my static folder. And the HTML files that I'm using are basically index.html, base.html, and recommendations.html. Now index.html is the front page, so the page that you see over here, this is index.html, and this is what it looks like. I'm going to put all these codes in my article and on my GitHub as well, so I'll share the link in the description below, you can check that. This is my front page, and this is my recommendation page. So it will just show the name and score of that particular movie, which are similar to whatever movie the person has searched for. So yeah, that is my recommendation.html. So once I have to show recommendations, then it will move on to the next page. And then I have base.html. This is just to make sure that I'm able to use Bootstrap. And then in static, I just have one CSS file, which is very basic. It is just to bring the table and the header, what you see here, in the center of the page. That's it. So yeah, that is how I'm building my application, and my application has restarted now. So I can just go ahead, I can refresh the page, and then I can search for whatever movie I want. So in the previous videos, what I have been searching for is the Prestige 2006. So I'm going to search for that movie again. It's a 2006 movie, and this is how it is there in my database. So that's how I'm going to search. And then I click on recommend. So here you can see the top 20 movies that are very similar to Prestige, and they are Dark Knight Rises, Interstellar, Memento, Batman Begins, Inception, Dunkirk, and these are like really good recommendation. You can compare it with the IMDB movie recommendation as well. If I want to search for some other movie, a very popular movie, which came from India recently, was RRR. And if I search for similar movies to that one, you can see here Magadhira, Thief of Yama, and Bahubali, The Beginning, and all these movies are again very similar to RRR, which was released in 2022. So yeah, this is how you build a recommendation system. And once you apply the dimensionality reduction, you can see that the RAM consumption is very less. In the Flask application, I don't think this, if you have any system which has 2 GB of RAM or 3 GB or 4 GB of RAM, then it should be very easy to run this Flask application on that system. So if you guys have any questions for me, you can write them in the comments below, and I'll be happy to answer. And that would be all for this video. I'll see you in the next video. Till then, happy learning.